Okay, so they have a nice little chart here. I can't remember what page it's on. Page uh, 801. But the idea is if 30 degrees was pi over 6, well, you could write them the same spot on a triangle. And that's the idea, or on a triangle, on a circle. So the idea here is we have these common angles 30, 45, and 60, and 90. And then we talk about what radians they are relating to them. And you can see that's pi over 6, pi over 4, pi over 3, and pi over 2. So if you know those four angles, well, then all you have to do is just kind of manipulate them a little bit, and you can figure out what all of these other groups of angles are, right? Um, it's one of those things you'll probably start out just memorizing 30, 45, well, probably the 90 in there too. 30, 45, 60, and 90. You'll probably just memorize those four at first. And pi over 6, pi over 4, pi over 3, and pi over 2. And then you'll memorize those ones and how they relate to each other, right? Which ones are equal. Eventually, you will get the whole circle. But for right now, you'll probably just start with the first quarter. And if all you can get is the first quarter right now, that's okay. Either copy this down or write down page 108 and know to flip back there as often as you need to. It's really going to be one of those things. The more problems you do, the more times you use these angles, the more you'll remember what the connection is to it. Like for me right now, it's been 11 years since I've taught this stuff really. It's going to be a minute even for me to remember that 315 is 7 pi over 4. And I might have to back at it on occasion. But that's okay. You're allowed to do that. It's one of those things, it's helpful if you memorize it. Definitely saves you time. Some people put more effort into it than others. If you don't put the effort in, you're just going to have to be flipping to this page a bunch. So just remember that. All right. But that's super helpful. Okay. Um, a central angle of a circle, I think we already even mentioned it, is just the the angle made by two radii of the circle, right? Like imagine the radii become rays and they go out forever. That's your angle. The central angle is just whatever measure it is inside. The intercepted arc, that's kind of like the idea of the radians there, is how much of the circle gets cut from that. But with the radians, we were just talking about it in general, or like with a unit circle, right? So the radius was just one. It was just kind of a measure of how far it is. Well, you can still use that idea of radians and the central angle to calculate how far something actually is. So we're going to be looking for something called arc length. And the idea is basically if you know the circumference of the circle, then you can figure out what portion of the circle is going to be um, left over when you cut it out with that angle. One way to find the circumference is you use the radius. So you can see here, arc length is supposed to be radius times the angle. Um, that angle there, it's very important to notice, is in radians. So how does that work? Let's just do a quick little example here, and let's make this have a radius of 4, and well, let's write that in here. Radius of 4 inches, right? And we'll have the central angle in here. Oh, let's have it be pi over over pi over 6. All right, just some random radian. So the length of that arc is going to be the radius, 4 inches, times pi over 6 equals, well, that reduces down to 2 pi over 3 inches. That is the arc length. Now, the way we would do this in geometry is you would take the radius, arc length equals the radius, times the central angle, whatever the central angle was, over uh, 360. It's the same thing. You would just take the central angle, whatever it was, in degrees, and you divide it by 360, and you'd see what portion of the circle it is. The nice thing about radians, it's already in portions of the circle. So that's why we like arc length being in radians. Now, let's go ahead and apply this. Monster truck tires have a radius of 33 inches. How far does a monster truck travel in feet after just 3/4 of a tire rotation? So 3/4 of a tire rotation. Think of it this way. We got a big tire, and we're going to start here, and we're going to rotate around 3/4 of the way. Well, what angle is that in radians? If you don't remember, you can go up to the top and look at that chart, or you can try to figure it out. And trying to figure it out every once in a while is a pretty good habit that helps you see the relationship between all of them. You probably might have recognized that pi over 2 is 90 degrees. So, and half of a circle is pi. If the whole circle is 2 pi, half the circle is pi. So what's pi over 2 plus pi? Well, that would just be 3 pi over 2. Think of it as it's pi over 1, right? Pi over 2 plus 2 pi over 2. I just found a common denominator, a total of 3 pi's over 2. So that's 3/4 of a tire rotation. That's 3 pi over 2 radians. All right. Now we just multiply that by the radius, which happens to be 33 inches. So 33 inches times 3 pi over 2. So 33 times 3. I might pull out the calculator for this one. Let's do that. We'll pull out the basic calculator, though, since we're not using sine, cosine, or tangent. It's nice to have a little break from those for a night. Oop. I don't need to have this maximized anymore. Okay. So 33 times 3 equals, and sometimes there's a nice pi button on your calculator. Here we happen to have one. Uh-oh. You didn't get to see that there. Now I'm going to multiply this answer times pi. It equals, and now I just have to divide it by 2. So I get 155.5 equals 155.5 inches. Now, 155 inches, I don't really know how much that is, so I'm just going to divide that by 12. That's what I'm just doing off screen here. And I got 12.95 divided by 12 goes to, well, I'll show you what's going on here. 155.5 inches times 1 foot over 12 inches. That gives us 12.95, which is basically 13 feet. So just by 3/4 of a tire rotation, this monster truck moves 13 feet. Pretty impressive. That's why people like monster trucks. Big old tires, they move very far, but you know, if you go slow, you can climb over the top of another car. It's fun, monster trucks. All right, I think that's the end of the lesson. The trick is to make sure that you are looking at it in radians. If you don't have radians for the angle, you're going to end up with a miscalculation.